Welcome back, Panthers, for part 2 of this video on formula mass and the mole concept. And we're going to take a look at one problem. We have 15.36 grams of magnesium acetate. And acetate you may or may not have had to memorize in your class, but that is a cation. Excuse me, it's an anion. And the formula for that is C2H3O2 minus. Acetic acid is based on that. And so using our rules for writing ionic compounds, magnesium is a 2+ ion, acetate's a -1 ion, so that's going to give us this formula right here. The 2+ is going to cross down and show up as a subscript for the acetate ion. So there's 2 acetate ions for every 1 magnesium ion in the balanced equation. So we have a sample, 15.336 grams of it, and now we got a couple of questions we want to ask. How many moles of this are present? How many total atoms are present? That means all the atoms combined. How many hydrogen atoms are present? How many moles of this ion are there? How many moles of this acetate ion are there? And how many total magnesium cations are present? These are all kind of typical questions you can get with this problem. So we're starting with one piece of information, and like 5 different questions can be asked by someone mean like me. So how do we do this? Well, how many moles? This one is a lightning problem. You should, once you get the hang of this one, you should be able to do this very quickly. So moles of magnesium, I'm going to write it with all the steps down. C2H3O2 sub 2. How many moles of that? That's going to be equal to my initial mass, 15.36 grams of magnesium C2H3O2 sub 2 times 1 mole magnesium C2H3O2 for every, we need to find the molar mass. And how do we find the molar mass? We need to take the mass of 1 magnesium, we need to take the mass of 2 times 2, 4 carbons, 6 hydrogens, 2 times 3 is 6, and 4 oxygens, 2 times 2 is 4. If you want to take a minute and calculate it and then come on back, we'll continue the video in a second. So you should have calculated a molecular weight for this for 142.40 grams per mole. All right, and when we do our calculation then, we need to get rid of grams, we want to turn into moles. That's the conversion factor we're going to use. The molecular weight or the formula weight is 142.40. So 142.40 grams mg C2H3O2, and I should have a little subscript of 2 up here. Okay, and then grams of magnesium acetate cancels grams of magnesium acetate, and this is then equal to 0.1079 moles of mg C2H3O2 sub 2. Okay, so my first question is moles of magnesium acetate. It takes me longer to say it than you should be able to do this calculation. So first we do need to calculate the molecular weight. If it's not given to you in the problem, that's the very first step you're going to need to do. And then you're going to have your mass times 1 mole per whatever the mass is. In this case it's 142. So now I have a number of moles of magnesium acetate. All right, so let's take a look at the next question. How many total atoms are present? I'm going to start with this number that we've already found. You could start all the way back at the 15.36. You'll just have these same 2 steps and then you go from there, but I'm just going to start with this number. So I'm trying to find total atoms. So when you see something like total atoms, you should be thinking big number. I mean, if this is something in the gram range, the total atoms is going to be something in the 10 to the 22, 10 to the 23, 10 to the 24. If you want the total number of atoms, or down here, how many hydrogen atoms, or down here, how many magnesium cations, you should expect a large number. How are we going to get a large number? We're going to have to get Avogadro's number into this calculation somehow. Okay. So how many total atoms is going to be my starting number of moles, 0.1079 moles mg C2H3O2 sub 2. Should have picked an easier one to write, times, now I need to find out how many atoms there are in this compound. There's actually two ways you can do this, but I'm going to do it, I'm going to make the conversion to number of atoms first based on moles, and then we're going to find the total number of atoms. So in this compound, there are 2 plus 3 plus 2, that's 5, 6, 7, times 2, 14, plus 1. There are 15 atoms in every one of these molecules. Okay, every one of these formula units, there's actually 15. Let's do that again. 2 plus 3 is 5, 6, 7, times 2, 14, plus 1, 15. There's 15 total. And that means if I have 1 mole of this, there are 15 moles of atoms. Just like if I had 10 soup cans or 10 cans of fruit cocktail, and there's 2 grapes in each one, I have 20 grapes. So if I've got 1 mole of this, I've got 15 moles of atoms. So my next conversion factor is going to be 15 moles atoms for every 1 mole of Mg C2H3O2 sub 2. Okay? And then that is going to cancel with that, and that's how many moles of atoms I'm going to have. And then my last step is going to be, moles is like a dozen, right? So my last step is going to be 6.022 times 10 to the 23 atoms for every 1 mole of atoms. Avogadro's number is just like a dozen. If I have 15 moles, that's 15 times 6.022 times 10 to the 23rd. Okay? So when we do this calculation, it comes out to 9.743 times 10 to the 23 total atoms. Okay, let's circle our answers we're getting. We're getting this one for problem number 1. We have this one for part 2. And this is a big number. We expect it to be a big number. Whenever you see total atoms, you're going to expect this to be a big number. Okay, how many hydrogen atoms are present? You could start here, but that's a little bit of an awkward way. Let's start back with the number of total moles. So how many hydrogen atoms are present? So I'm going to say hydrogen atoms present. We'll start with the same information we had above, 1079 moles Mg C2H3O2 2 times. There are 6 hydrogens for every one of these units. So this is actually the exact same type calculation as the prior one, only now we have 6 moles of hydrogen for every 1 mole of Mg C2H3O2 sub 2. Moles magnesium acetate is going to cancel moles of magnesium acetate. And again, it's asking for how many total atoms. So we're expecting a large number. So now we're going to have to multiply one more step times 6.022 times 10 to the 23 hydrogen atoms for every 1 mole of hydrogen. That's going to cancel that. That's going to give me hydrogen atoms. Now you might be thinking to yourself, well, how come you just had atoms here and you had hydrogen atoms here? Remember, a mole is like our dozen. You can have a dozen eggs, you can have a dozen puppies, you can have a dozen cars, you can have a dozen pencils. You can have a mole of hydrogen, you can have a mole of atoms, you can have a mole of molecules. Okay? This is our way of grouping it. So when we have a number of 6 moles, if I want to find out how many that is, I just multiply it by the mole of whatever it is I'm interested in, mole hydrogen, and 1 mole means 6.022 times 10 to the 23rd. So as long as I'm writing the units down consistently, I should be able to see where I'm trying to get with this. So this guy is equal to 3.900 times 10 to the 23 hydrogen atoms. Okay, why don't you try the next two by yourself? See if you can figure out how many moles of acetate ions there are that are present. Again, we're going to start with the number of moles of magnesium acetate that we found earlier. How many moles of acetate ions are present? And then also how many, this means total number of magnesium cations are present. So let's take, you can stop the video, work through it, and then we're going to come back and see if you were able to figure that out. Okay, just like a cooking show. You do some magic, you stick it in the oven, and then 10 seconds later they pull something out of the oven, even though it's had to take 40 minutes to cook. So moles of acetate anions. So we're going to start with we're looking for moles of acetate anions. We're going to start with the number of moles we found before, 0.1079 moles of magnesium acetate. And then we notice that there are 2 of these acetate ions for every 1 molecule. Okay, key idea. 2 acetate ions, that's what the subscript 2 means. That whole thing's grouped together. The little subscript 2 means there's 2 of them for every one of these molecules. So I can say that there are 2 moles of acetate ions for every 1 mole of magnesium acetate. Those will cancel each other out, and I'll get 0.2158 moles of acetate ions. Okay? And finally, how many magnesium cations? What's the total number of magnesium cations? The total magnesium ions, we're going to start with the same number, magnesium acetate 0.1079. We've got 1 mole of magnesium ions for every one of these molecules. So 1 mole Mg2 plus for every divided by 1 mole magnesium acetate. That cancels that. And I should do the next step. 1 mole magnesium 2 plus cancels 1 mole magnesium 2 plus for every 6.022 times 10 to the 23rd magnesium cations. Remember, this quantity is like a dozen. I can have a dozen cats, a dozen chickens, a dozen horses. I'm doing animals right now, a dozen eggs. We can have 6.022 times 10 to the 23rd magnesium ions, hydrogen atoms, total atoms, molecules. They're all grouped together, but whenever we have mole as our last factor, we can use Avogadro's number to find out the total number of them. All right, so let's quickly recap everything we talked about. First of all, this is a topic that gets used all the time, being able to do this calculation. You start with some mass, and you can find all of these different type quantities depending on the starting mass. So if we have a starting mass, we always need to find the molecular weight or formula mass of this. That's the first step. Once we find the formula mass, we can convert it into moles. That's the second step. So grams get turned into moles using the formula or molecular mass. From there, there's a lot of different questions that we can answer. We can find out how many total atoms there are, find out how many hydrogen atoms there are. I could have asked how many carbon atoms there were. I could have asked how many oxygen atoms there were. We did ask the number of ions, both moles of ions and number of ions. I could have also asked what's the mass of the cation of the magnesium cations. So if you want to try that to find out what the mass of magnesium cations is, you start at the same place, you find the number of moles, and then you use magnesium's atomic mass or molar mass to figure out how many grams of magnesium there actually are in the sample. Okay, this is a good overview of the types of problems you can see. This is a key concept in Chapter 3. This sort of unlocks all the rest of the stoichiometry chapter in Chapter 4 and 5, as well as many, many subsequent calculations throughout this semester and the next semester. So this topic right here, I can't emphasize enough. This is a key conceptual concept. You need to get this down in order to be successful in general chemistry.